General solutions. To be honest, it's my least favorite section of Trig because it's quite tedious, but it is quite impressive in the sense that it's the culmination of all our identities coming together. That plays a role first, and then it's some equation solving. Your knowledge of graphs even comes into play sometimes. So this section is quite meaty. Let's get into it. I've just listed a couple of tips. They may seem confusing at first, but once we run through the examples and then you read through these tips again, it'll make more sense. If you can simplify a given equation to have just one trig ratio all alone, then it's the most straightforward. But if you cannot get one trig ratio all alone, you usually need to create a trinomial using your identities, which you will then factorize into two brackets, and you'll follow the general solution process twice, usually ending up with 4 possible theta equals blah 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 plus k360. When you see a sine and cosine and the same angles, you divide by cosine to turn the equation into one that is of tan, because sine divided by cos will give you tan equals a number, and then you can find your reference angle using arctan or shift on your calculator. But when you see sine and cosine and different angles, in other words, one could be theta and the other one could be theta plus 30, then you need to use the cofunction rule to change the sine into a cosine or the cosine into a sine. It's etc. Right. These are so if you have a look in your textbook, and I recommend that you do look at example 13, 14, and 15, starting on page 150. Please go over those examples in conjunction with the examples I'm going to present to you now. You will see that the textbook gives you two methods. Now, the method we use is method 2, which is the graphical method. Method 1 works perfectly fine as well. They are very similar in any case, but we're just going to choose method 2 and stick to that. And the nice thing about this one is that it gives you 3 little formulae that you should just memorize. And the formulae apply to each trig ratio. There's 2 for cosine, because if you think about it, there are 2 quadrants in which cosine is positive. The plus theta quadrant and the negative theta quadrant, plus reference angle, minus reference angle. Then you get the sine. This formula comes from the quadrants in which sine is positive, which is the reference angle, and 180 minus your reference angle, so quad 1 and quad 2. And then tangent, also one little formula to remember, because tangent repeats itself every 180 degrees. So your reference angle, so the tangent is theta is equal to your reference angle, and theta is equal to your reference angle plus 180 degrees, quadrant 1 and quadrant 3. Something very, very important to remember is to always write k is an element of integers. We cannot have k be a fraction. It's got to be an integer because it represents the repetition of that specific value, y value, when you are given a specific theta, an x value on your graph. So the k links up to the period of the graph. Another thing that you need to realize and remember to do is take a deep breath and know that you have got this. Let's go on to an example. Here we have to determine the general solution of something that I hope to you looks pretty similar to a trinomial. Let's see what we can take apart here. Perhaps the middle term, sine 2 theta. Remember, there's only ever one option for a sine of 2 theta, and that's to apply the double angle identity. So we replace sine 2 theta with 2 sine theta cos theta, and hence in our next line we have a 4 sine theta cos theta, because the 2 and the 2 multiplied together. Apologies for not including that one little extra step, but phew, there are a lot of steps to general solutions. There's the identity that was used for your for you to mull over how we got from 2 sine 2 theta to 4 sine theta cos theta. Now you can see that we can factorize this into 2 brackets as a trinomial. If you were to FOIL out this bracket, you'd get back to that first line. So now we have 2 options. The one bracket equals 0 or the other bracket equals 0. Do you remember my first slide? I said when you see a sine and a cos and you have the exact same angle as in theta, 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 we can divide everything by cos theta in order to get a general solution in terms of tan. Sine over cos became tan, and over here our sine over, and if you make tan the subject of the formula, you get tan theta equals -1/3. Other side, we're going to, our sine over cos became tan, our cos over cos became a 1, and we make tan theta the subject of the formula, and you get tan equals -1. And now we solve for the reference angle of each of those. To find your reference angle, you use arctan on your calculator, so you just press shift. So you shift tan -1/3 and you get -18,43 degrees. Now the general formula for the general solution of tangent graphs is up at the top. So our general solution for this one is just theta is -18,43 plus K180. Other side, reference angle equals arctan, so we press shift of -1. Although I hope you remember that tan is in fact y over x, and your gradient formula is also change in y over change in x. So if you have a gradient of 1 and your line is going through the origin, I'm pretty sure you can imagine that this line is making a 45-degree angle between the line and the x-axis. All right, if your gradient was -1, the angle it would make would be -45. If you don't get that, that's fine, just use your calculator. Plug it into the formula, and voila! Are we missing something? Yes, we are. K is an element of integer. You are welcome to only write it once per page, because every time you see a K, it means that that K represents an integer. But if you want to be safe and you will write it twice for each situation, that's perfectly fine as well. And although it's long and it's tedious, it's not complicated. So it's just so easy. Ready for example 2. Here we have to determine the general solution of sine half theta cos half theta equals a half. Now please do not make the fatal error of thinking you can multiply this entire equation by 2 in order to get sine theta cos theta equals 1. That's bad news, because those 2's on the left hand side of the equal sign are part of the angle. It's not sine theta divided by 2. It's sine of theta divided by 2. I know it sounds like I'm repeating myself, but it's the half of the angle, and you can't divide by a degree. Right, so we've got to link this back up to our double angle identity for sine. If you look carefully at this identity, the x's on the right represent the single, while the x on the left, the 2x, represents a double. So if we draw our eye back to this equation, maybe I need to get my pointer out. If you draw our eye back to this left-hand side of the equation, we link it back up to the right-hand side of the identity. So if the right-hand side represents the singles, so x over 2 is the single angle, the double angle will just be 1x. So a half x represents one single, then the double will be 1x. So in our next line, oh, and don't forget, if we want to get rid of this 2 on the right-hand side, we can divide both sides by 2, and we end up with a half sine x on the left. So that's what we're going to get for our equation. We end up, so this whole sine half theta, cos half theta, if you allow your thought process to follow this, you'll realize we can write it as a half sine theta. And now it's really, really straightforward, because we can either times both sides by 2 or divide both sides by a half, whatever works for your brain. We end up with sine theta equals 1. And voila, we can set up our reference angle situation. So our reference angle is 90 degrees. You can get that by using your calculator, or I hope that you can remember your sine graph. And you can imagine at 90 degrees, our corresponding y value is 1. So if we're given a y value of 1, we should know that we're dealing with 90 degrees. In the relevant quadrants, let's go. Theta equals 90 plus K360, or theta equals 180 minus 90 plus K360, which means we're just repeating ourselves, but that's okay. Follow the process so that your brain can get used to it. And example 3. Solve the following for beta, if beta is an element of negative 180 to positive 270. First things first, I'm sure you can see we once again have a double angle identity for sine, so we can replace sine 2 beta with 2 sine beta cos beta. And what do you notice? Do we have a highest common factor? Yes, we do. Take it out, and we now have a product that equals 0. So either cos b equals 0 or 2 sine beta minus 1 equals 0. Now we've got to solve the general solution twice. Once for cos beta, once for sine beta. I'm going to work on sine beta first. If we make it the subject of the formula, we kick the 1 over, we divide both sides by 2, and you get sine beta is a half. So you pop a half into your calculator to get your reference angle, or you can be a clever cookie and think, if a half is my y value on the graph, what would my corresponding x value be? Yes, it would be 30 degrees. Now we apply our formulae. Theta is the reference angle plus K360, or theta is 180 minus your reference angle plus K360, which boils down to being 150 degrees plus K360. And we are not done yet. Let's go back to cos. If you want to find your reference angle, you pop it in your calculator, or you remember your cos graph and think, when my y value is 0, what is my x value? Yes, it is 90 degrees. So let's pop that into our general formula for cos. Theta equals your reference angle plus K360. So theta equals 90 degrees plus K360, or theta equals the negative reference angle plus K360, which is negative 90 plus K360. And then, are we done yet? No, we are not. Why not? Because we haven't said k is an element of integers. And now look back to the question. Beta is an element of negative 180 to 270 degrees. So what we need to do now is take each of these turquoise rectangles and substitute the possible values of k. For example, we've got to let k equal 0, k equal negative 1, k equal 1, etc. And once you do that, you check on your calculator to see whether your answer lies within its interval. If it does, you jot it down. And these should be the numbers that you jot down. Sorry, I haven't shown the substitution, so please let me know if you need further explanation. I'll gladly help you. So that bottom left rectangle with the curly brackets is your final answer. And if you have any queries, please let me know. This video is long enough, so good luck with the homework. Reach out to me if you need to, please. Thank you. Goodbye.